talk about a logical approach to cosmology.
Exactly.
Right, okay. Well, I don't know any more than that, so you might as well start. Thank you.
How much time do we have roughly?
Well, we have,
20 minutes?
including, yeah, if you can present for 20, but then we can have discussion.
Yeah, okay, so I think it would be best for us to work that way. So I'll ask you 6 questions, and I actually plan to leave them on the board, so you can kind of think about them in the process, and you can give them an answer of your own, and after that I'll try to answer them from my point of view, and we'll see if we agree or not, and hopefully there will be some discussion afterwards. Okay, so when we're talking about cosmology, one of the, which space would I need? Well, let's try that much. So the first question I would ask to you is, how many universes are there?
None.
One. It's in the name. It's in the name.
Not none.
Okay, that's the first question. The second question would be, let me just consult my notes a little bit. Okay, is the universe, or universes, finite in space?
Nope.
I'm sorry.
Just put a U.
It's a great question. Finite in space.
In space, yeah.
Is that not tautological?
I don't know. We'll see. In space.
Black space or white space?
So the third question that I would ask would be, is it finite in time? Well, I'll just denote the universe like that, for sure. The fourth question I would ask would be, does the universe have a definite size? Like,
By size, you mean mass or what?
no, spatial size.
Isn't that the first,
Second one.
or the second question? No, sorry, isn't that
Well,
question two?
some of them are connected indeed. Well, let's just. So the fifth question I would ask would be, can the universe expand? Obviously connected to the previous one. And the sixth question would be, does the universe has a definite mass, charge, or some other properties like that? Or have? I don't know. My English isn't very good. Charge, etc.
So how about, is it a closed system? Could that be a
Well,
second?
I wasn't. I did not ask that question. Although you might say that it's implied. in some
Well,
way.
that's in number 5, isn't it?
Okay, so I'll try to answer those questions from, again, my point of view, and some of the principles I would utilize here would be a philosophy of positivism. I'll describe that in a couple of sentences a little bit later. The principle of causality, which I can also describe to you in more detail, but I think it's self-evident.
Yeah,
Like, actually, a lot of things I would be talking about, you can explicate logically, but that would just take some time, you know, so I'm simplifying a lot.
Yeah, perhaps just define the meaning of the word universe. It means turning as one, universe.
Okay. I'll give my definition of the universe.
The Oxford English Dictionary will not define.
I just like explicitly state the principles I use so that, you know, if there will be any questions about that. And the third principle is I would use the Cartesian approach to what a physical body is. I would basically consider a physical body anything that has size, basically. Whereas, you know, there's like Newtonian approach where a physical body can have no size also. You know, a mathematical dot might be a physical body according to Newton, but according to Descartes, it cannot be. But those are just the principles. So the philosophy of positivism, it appeared in the 40s of 19th century, so 1840 something, and it was sort of like a response to Hegelian philosophy, which was really popular at that time, you know, German classical philosophy, where people invented, you know, all kinds of stuff, all kinds of metaphysical objects, like the world spirit of Hegel, like all kinds of stuff. So positivists said, you know, in science we better not invent stuff that we don't observe. So that was the main point. Like we should only work in science with objects that we can interact with or observe, which is the same thing. Like observation is a particular case of interaction. Okay, so this is what I'm gonna use. So I'm gonna give the first definition, which would be my definition of the universe according to those principles. So we'll say definition 1. The universe is, and again, I'm going to be doing that in plain English, let's say. I can use like quantors, you know, like logical, this bird speech, but I would use just regular English. So it's all the stuff, sounds pretty simple, right? It's all the stuff that we can interact with in any possible manner.
Or in
Got rid of
that.
97% of the
You mean receiving light from a billion light years away that's interaction.
Yeah, I consider that as an interaction. Because it influences us in some way, right? Okay, so that would be my definition for the universe. So, I'm gonna try to answer those questions following the logic of the proof by contradiction, basically, you know, reductio ad impossibilite, as it is called. So, let us assume, like, let's start with the first question. Let us assume that there are many universes, like there are parallel universes, etc. What would happen in this case is, if we can interact with those universes in some way, it means that by definition 1, they would be part of our universe because we can interact with them. But if we cannot interact with them, according to this principle of positivism that I've stated, we can just forget about them. Since we cannot interact with them, what does it matter, you know? They don't exist for us. So that would be my question for my answer to the first question. We only have one universe according to this definition. All right? Hopefully that was clear enough. I'll kind of summarize it all in the end, hopefully. So, the second question. Oh damn, it doesn't work. Okay. Okay, forget it.
We can sell the blackboard like they did for Einstein.
I would just need some space later, that's what I was wondering. Alright, so let's just say it's the second question right now. The second question is the universe finite in size? And here I would have to give two more definitions, unfortunately. Perhaps, so. Oh, that's great. Thank you.
Oh, look, matter. How amazing is that? Okay, I've still got some paper left on here.
So, I will give you a definition. Yeah, now I've screwed the marker here. Can you see that?
Yeah.
Okay. So the definition 2, I'm introducing that to answer the second question, would be, is that an object is finite Has a border.
I don't know.
Okay, seems kind of self-evident. If the object is finite in space, then it should have some border, right? And I would give a definition of a border also.
That's
I'm
it.
not sure if it's enough space.
Mechanics, right?
Yeah. Unfortunately, the board is very finite in space. So we would say that a border of going here back of one object with another. I'll go like that. So, we're saying that an object is finite if it has a border, whereas we define a border as this surface through which the object interacts with some other objects, all right?
Like a threshold.
Yeah, and I've given some illustrations here, like if we say have an object A, and we have an object B here, so I would call this a border, this thing in between it. Or if we have an object B around the object A, then like basically this whole thing would be the border of the object A in this case. Okay, so following that, let's assume, again using the same vehicle, the same proof by contradiction, let's assume that the universe is finite. What would that mean, according to these definitions, is that by definition 2, the universe should have a border. Okay? And by definition 3, the universe having a border means that it should interact with some other objects. But according to definition 1, all the objects are included in the universe. So there are no objects for it to interact with, therefore it doesn't have a border, therefore it's not finite. Okay? Yeah, so the answer to the second question, no. At least my answer. Let's examine the third question. Is the universe finite in time? Well, I give another definition here. Definition 4.
You're right, Rob. Do you want to
Like,
take over? Okay.
to be finite in time, yes, means to come to existence at some point or to disappear at some point, or both. I'll just simplify and write or disappear.
Perhaps this is more the cosmos you're talking about. The word cosmos, the idea of what's finite, something finite.
Well, I gave my definition of what the universe is. You might give it another
No, it's a
definition.
different word, different term, I'm saying. The Greeks
Well,
have
I'm using
cosmos.
this term. I gave a definition explicitly. Okay? And again, let's assume that the universe is finite in time. So it appeared at some moment, or it would disappear at some moment, etc. And again, according to that principle of causality that I've introduced at the very beginning, basically from the definition 1, it would follow, like, the principle of causality means that each reason has its consequences, or each process has its reasons, and vice versa, right? If all the objects belong to the universe, then the universe can have no reason. So causality, the fact of appearance of universe is incoherent with causality, inconsistent. Or the fact of disappearance of universe is also inconsistent with causality. Because there are no other objects to be a reason for the universe, or be a reason for the disappearance of the universe, exactly. So, my answer to the third question is also no. Universe is not finite in time. Again, according to the principle of causality. Okay? All right, let's examine the fourth question. Does the universe has a definite size?
Like the second one.
That's a little bit of hand waving here. Gonna happen now, but again, as I've said, you can explicitly write it all down. I'm just simplifying things, all right? So I would say that a size is, well, I would omit some of the words like determined as a blah blah blah. I would say they're just a distance between the opposite borders. So, I'll give you an illustration right now. So if we have an object A that interacts with object B through some border, and we have an object C that also interacts with object B, we call that a size.
So it's a relative
This
term.
X. Yeah.
Relative.
So we call this distance the size of the object B. Or you can, measure it using other borders or whatever, right? But if we assume that the universe has a definite size, right?
If we assume the universe has a border,
Yeah,
and
so
interacts with
we
something
come
else.
back to our
Two.
to our proof that the universe can have no border because there are no other objects for it to interact with, blah blah blah. So it cannot have a definite size also. There's just no way of determining that. So the answer for the fourth question is also no. Now the answer, let's examine the fifth question. Can the universe expand? Now I would have to give another definition of what expansion is. Can we? Is there?
Doing well.
it's infinite paper.
Okay.
Expanding.
Yeah. So I have this
It's okay.
no problem.
You're doing
Definition
well.
6 that says. Okay, I introduced various new terms here, but basically expansion of object A means it's actually very easy to just use the regular logical quantors to describe that. I'm just using regular language. So it means the integration or inclusion, you might say. Yeah, actually, probably should say inclusion of object X into A, where this X previously belonged to some other object B.
But that's moving into a space, it's not the thing expanding itself, is it?
I'll give you an illustration right now. So we have a situation 1, let's say, where we have object A and B, and we have some other object X that's kind of included in B. So this is like the first situation, but in the second situation, we have this object, should have really, this border shouldn't exist, but I'm just showing this object explicitly. So in the situation 2, we would have A, B, but now X is kind of the member of A. So in this case, we can say that A expanded, because now it includes some extra elements, right? Okay, so let's assume that the universe can expand. But how is it possible? Like, it should, for it to expand, it should include into itself on some, later moment in time, some objects that weren't there previously. But by definition 1, all the objects are already there. So there are no objects to be included anymore. So therefore it cannot expand. This is my answer. So the answer for 5 is also no. Alright? What is the sixth question? Does the universe has any definite mass or size? Okay, charge, yeah, sorry. So, well, I'll just, I wouldn't write anything anymore probably. I'll just use plain words. So, I'll say that the mass or charge or other properties like that might be, and in fact are, defined through the interaction of one object with another. Like we can say that mass can be defined as a, let's say, amplitude of gravitational interaction with another object. Or charge might be defined as an amplitude of electric interaction with another object. Right? So the more charge you have, the stronger you interact with other charges, other objects that interact electromagnetically. So, since by definition 1, there is no other object except outside the universe, let's say, there is no objects for the universe to interact with in the first place. So therefore, we cannot determine the mass of the universe, or the charge of the universe, or other properties like that.
Can't we do it
Was that-
internally?
Huh?
Can't we define it internally?
You might, maybe, if the universe, like, you might count all the objects in the universe and take a sum of their mass,
Yeah.
but you would have just a sum of their mass. Like, you cannot say that it's the mass of the universe,
Okay.
because there are no other objects for it to interact with. You see? Well, you can like just define the mass of the universe as the sum of all the particles. And again, under the assumption that there is a finite number of particles, let's say. But anyway, that there's this problem of the lack of external observer, if you like, for the universe. So the universe as a whole does not have these properties, this mass, because it cannot gravitate to other mass, the charge, because it cannot attract or repel from other charges, because all the charges are already there. So these are my answers, basically. How many universes? Only one? Is it finite in space? No. Is it finite in time? No. Does it have a definite size? No. Can it expand? No. Does it have definite mass, charge, or other properties? No. In fact, I would say that...
Here?
Huh?
Are we here?
No.
That's a good point. In fact, you know, there's this notion about the heat death of the universe, and I'm not sure that you can define the entropy of the universe. If it's not finite in size, like what really entropy is let's say the degree of ordering of energy in the system, right? So you have to have these borders, this vessel in which you're measuring the entropy, so that you can clearly say, well, okay, we have that much space, that much energy, and it's distributed like that. But if you don't have volume in the first place, how can you define entropy? So these whole notions about the heat death of the universe, I don't think they're valid in this regard. And obviously from that, Big Bang is also rubbish, right? Well, probably this is the main conclusion that I arrive at.
Yes.
So I'm not sure if I have anything else to say. No, there's one thing. So one other thing that we can derive from that in practice, let's say, is when we're defining, when we're determining, when we're developing, let's say, theories of how it all might work, I think if the conclusion that we can arrive from here is that the universe is pretty much, well, seems infinite and eternal, it means that all the processes should be balanced in it in some way, right? So let's take, and we actually talked with Ido about that quite a lot, like, let's say if we have processes of fusion and fission, they should be balanced.
But how can they be balanced if there's no centre? If it's infinite, there can't be a centre.
That's a good question, yeah, indeed. So, let's say locally you can have these, for example,
Yeah, but
structures,
without
right?
a boundary, how can you determine balance?
Yeah, that's a good question. But my idea is that they should still be balanced because
Balance with what?
mutually, the processes of creation and destruction. That's what I'm saying. But that's what I'm talking about. So if you have that much heavier elements produced from hydrogen, you have that much, the same amount kind of destroyed into hydrogen.
That
again.
sounds like you're trying to reintroduce the entropy thing.
No, I'm
In
not.
the sense that you're trying to work out something that grows in the
The argument here is that since we've probably had infinite time before that moment, all these processes could have occurred infinitely many number of times. So if they were not balanced, well, something would show up from that, right? And well, this is the reasoning. Well, but I understand. Yeah, it's problematic. Yeah, you might attack it from many angles.
Because when you said you couldn't determine the mass from the internal thing, but then you're talking about balance on the internal thing.
Well, I can describe that in a more abstract, vague terms. Like, let's say, what's going on, what the physical processes is some, abstractly speaking, some sort of flow through some sort of boundary, and what I'm saying is that there should be a counterflow in the other direction for things to be as they are.
So the destruction of stars and galaxies and the birth
Should be balanced, by the creation of stars.
Redistribution of...
Yeah, but there might be local, let's say, inhomogeneities, obviously.
But if it's infinite, why would it need to be balanced?
Well, because it had infinite time, if it was a little bit imbalanced, it would kind of skew infinitely many into one.
But you wouldn't even know that.
Skew it away.
Like, let's say, if fusion processes were a little bit stronger than fission processes, we would have only heavier elements remaining. You see?
Why?
Because there were infinitely much time for them to accumulate.
Much material at the beginning.
Huh?
There's
no
infinitely
beginning.
much light material at the beginning, maybe.
Well, I'm saying that there is no beginning, you see.
But when this matter energy generate itself, I mean, if it's infinite and it's always been here, how does it seems to propagate in places
Do we still need our poster?
Well,
Obviously, electrical
yeah,
force comes from
Rolf,
sunlight.
can we thank Rolf? There was a question about the energy. So, again, I've explicitly stated the principle of causality, and one of its consequences is laws of conservation. Conservation of energy, momentum, angular momentum, which are all violated by Big Bang, by the way, and also charge, and also all other kinds of conservation laws. So, we have these laws of conservation, it's no doubt. So energy doesn't have to be, you don't have to have input of energy into the universe because it's already there, it's just transforming from one form to the
How
other.
is it then? That's the question.
Well, what do you mean by how?
Well,
Well,
how is, I mean, I suppose that's the answer to the
Well-
question of how is the universe existing in the first place.
Well, the physical
Again,
laws.
not a valid question.
Oh, but
What is energy?
one simple
Causality.
statement from that is that if there was going to be a heat death, it would have already occurred.
Yeah, that's a good point, by the way.
No, but we're special, so it hasn't.
I don't know, like,
Yeah. I mean, it all stems from the definition of, what universe means.
Yeah, exactly.
It all follows from that.
That's why I
it's just the
explicitly
one and it's
stated at
all.
the very beginning.
So I mean,
What do we live in darkness?
you either subscribe to that or not.
yeah, I absolutely
everything-
agree. That with different definition, you can have like whatever conclusions you like. That there was a,
Yeah, sure.
So, one of the things in one of your definition is that we can interact with.
yeah.
And I just want to now, I'm sure you're okay with this, realise that the self-differentiation from the infinite is a local or arbitrary notion. So this is not to take away our fun and definitions and following and feeling, but that there is something integral to the universe in every act, in every thought. Is that right?
Well, I would say that I'm not sure what exactly you mean, but from my
Inherent, integral, that only the universe is capable of holding this conversation.
well, I don't know.
We have maps of self-differentiation that explicate as a universe.
I feel
Of
like
definitions.
you're kind of already moving into that metaphysical area that I try to stay away from.
Think of yourself as a local
I've noticed
disturbance.
you.
That's why I mentioned that I
I
use
won't try and
positive.
push my point, but I think without self-differentiation, there's no experience, there's no relationship, there's no anything.
Okay.
Experience. There's still everything, but to have an experience of everything, you have to have a local experience.
I can agree with you,
So you have to
even though
have
maybe this is not what you meant, but I can agree with you that the word interact is very vague, like it's super vague.
Yes.
You can...
Yeah, I might not be aware of other universities interacting with me.
And the word we.
yeah. So, yeah, I agree that, yeah, you can attack that system, and in fact, yeah. But this is what how positivism, I would say, views the universe. But if you attack that, I would have to use post-positivism to answer.
Post-truth world.
Yeah, I think. Well, I think it's very important to once you have some definitions, then work them through. And of course, as Eugene's pointed out, you can do different definitions. Now, one of them problems is about different types of infinity, because you see, the Big Bang says, oh well, it started, but there's one version of Big Bang that goes on forever, so it's infinite, but you can't go backwards in time. Whereas in the case of the space, you're just going outwards or not. You see what I mean? So there's different types of infinity. Now, before coming back to that, the idea the energy is all started from nothing. Well, and that has finite energy now. Well, that isn't true, because in the Big Bang idea, one version of it, is the total energy of the universe is zero, because the gravitational energy is negative, and the mass energy is positive. So in the beginning there was nothing, and then there was a bang. I mean, of course, I have difficulty coping with the Big Bang theory, but you know, the Big Bang argues, or can do, one version of it, that the total energy of the universe is zero. And as it expands, then the gravitational energy is used up, or the mass energy is used up to overcome the gravity, so it'll expand into eventually nothing, you see? From nothing to nothing, see? So, now, the next thing is about multiverses, as they call them, and I've argued with various theoreticians on this. I agree with your definition, there's only one universe in the terms of if it's something we can interact with, it's part of our universe. However, it's the problem of the vocabulary they use, really, because when they're saying this, they mean, well, there are other, let's not call them universes, let's say verses. Other verses out there
Great song.
we can only interact with very weakly through extra dimensions or something, but nevertheless, there are kind of influences which may happen or do happen under certain circumstances. And that way, that's what they mean when they talk about multiverse.
Yeah, but then there would be
That's part of a universe.
There is a connection, yes.
Yeah,
So
then
it's
it's a
not.
connection.
So it still is one universe, but the multiverse idea is about, you know, weak connections with another a whole. Well, things big as us, if you like, but weakly connected.
It's not always like that, because, for example, you have the many worlds interpretation of quantum mechanics, where these parallel universes do not interact. And why do you need them?
Yeah, but if they do not interact, then they're irrelevant. There has to be some,
Yeah,
exactly.
some link,
That's what I was saying.
some wormhole or something.
But through the wormhole you would have an interaction, and then it would be the part of the universe. So
Okay. And the last point, just to illustrate this thing about infinities, parallel lines. I'm reliably informed that you can have various definitions of parallel lines, and when you apply them in maths or in maybe quantum mechanics, you get different answers. One parallel line is lines parallel, as we say, and they never meet. Another one is they do meet at infinity. Okay, and there's a difference when you apply it in mathematics. I mean, you know, like taking limits of something tending to zero over something tending to zero. You can get finite numbers or whatever depending on the rules you apply. You see, so within what you're saying, there is many assumptions.
Yeah, okay, there was another thing I wanted to add, probably, also connected to this many universe thing. It's this idea that the universe is a simulation, you know? Like there's some cosmic computer that runs the simulation. So I would say that according to this approach, if there is a way, any way, for us to interact with the real world beyond that simulation, then yeah, this theory is valid. Because, well, this world exists for us, because we can interact with it, at least in some vague way. But if we cannot interact in principle with this external world, then again, we can just say, well, whatever, it doesn't exist. If it's a simulation, like, who cares? If we don't have access to the real world. Right?
Can I ask you a question about entropy?
Yeah.
I mean, if we're going to say that everything transforms into something, then how can entropy work in that context?
It works just statistically, let's say. So, you see, actually thermodynamics is a topic that needs serious revision, I would say, in the first place. Because they're only considering heat type of interaction, just random collisions, whereas heat is electromagnetism fundamentally, etc. The motion and interaction. So, okay, but how they interpret it is that, again, we have some volume with some whatever matter in it. And the entropy is a measure, according to the statistical mechanics approach, of how likely would this particular type of arrangement be. So if you can, like let's say, okay, let me draw this classic illustration. If we have a volume that we can, let's say, separate in two parts, and we have, let's say, two particles for simplicity, we can have that type of arrangement where one particle is in one box and the other is in another. Okay, let's actually name them. It's particle A, it's particle B. We can have another arrangement where particle A is here and particle B is here. And by the way, we consider them the same. Like, we cannot tell the difference. And we can have those types of arrangements where both of them are in one, or both of them are in another piece of volume, right? And statistical mechanics says, well, you see, there are two options for that type of arrangement, and only one for each one of those. So this one is more likely if everything is random, right? So and this system has more entropy, because it has more ways of being achieved through some kinds of processes. So this is the foundation of this second principle of thermodynamics, or sometimes it's called second law of thermodynamics. But again, the very processes that these particles interact with each other, with the walls of this volume, is something that nobody speaks about. Never. You would never see that, oh, these particles interact in such a way, there's such a potential, it behaves like that. No. They just say, well, let's assume there are particles and they rearrange in some way. And I'm not really happy with it.
And you always have to have a fixed boundary.
So if we're assuming that there is one universe, and that the definition of that is the sum of all the things within or that it interacts with, and that we as planets, stars, human beings, etc., are within that universe, then we are that which is the universe. So is it we are part of it? We are.
Yeah, definitely.
You are local disturbance.
Is it possible that these laws or assumptions could also be applied to particles?
Well,
I mean, not being finite, not being separate, distinct, not being other, but all part of perhaps like a one electron theory type of. There is only one.
Well, my short answer would be no. But like there's a whole bunch of other things we need to talk about to clarify, which I don't want to do right now. Sorry. Short answer is no.
Is there such thing as a borderless universe?
Well, that's how I define it.
But exactly, by definition.
Okay.
Cool. Well, I think Eugene has completely fried our brains.
Success!
I have one also addition with regards to cold fusion, actually, with regards to what I mentioned during Q&A at the conference. I was thinking about this a little bit more, this esprit d'escalier, like what I should have said, actually, So I was thinking about it, and I came to the conclusion, it's a very simple binary scheme, so it's very conditional, but how people try to achieve fusion right now, it's exactly through this maximal entropic type of interaction. They try to achieve it with heat, which is the least organized form of energy fundamentally. So I'm saying that the cold fusion should be like the opposite of that, the polar opposite. It should be a very organized type of energy. So that's why I was saying there that we should have some sort of coherence, vaguely speaking, some sort of focusing, organization of this energy that we would use for cold fusion. So, and I was answering Pierce's question, like how much energy do we need? Maybe we wouldn't need much
That's
if we,
what I agree
if
with.
we organize it in precisely manner that is necessary, right? But this is a very brute force approach through temperature, you know. I don't think it's the way forward. Yeah, thank you.
Right, well,
that's the end.
anybody else got something else to say? Sorry.
Well,
Yeah, please.
just wanted to add something very small. You put these boxes and you seem to be therefore ridiculing statistical mechanics. I'm not sure, but you see, in statistical mechanics, those spaces, hyperspaces or whatever, or grand canonical ensemble of boxes, they are mental spaces, if you see what I mean. They're not physical spaces. You just have the momentum of all the particles defined and their energies and so on. So then you're arguing about the different occupancies of these boxes.
Phase space.
Phase space, that's the word. Sorry, I must be tired or something. But with the phase space, because it's just a question of measurements or defining things rather, you don't need to get into this thing about moving from one to the other. Well, I think I'm just trying to say I don't think your argument there is actually a valid argument against the concept of phase space.
Okay. that might be the case, in fact, I don't know, to be honest.
It was just a mental construct then.
Yeah. It's a mental construct. Phase space is a mental construct.
That's totally true.
Without just putting aside my thing about the we that was presumed or defined in this, that one of the things that I interact with all the time, or interacts with me all the time, is thought.
Yeah.
Which I just wanted to mention that because that is part of our capacity to model and part of our capacity to live in the model, sometimes without any awareness that we are in the model and not in a real, or how should we say, not aware of our relational being, because we're so in our own bubble, if you like, of thinking.
Yeah, I totally agree with you, and that's probably the most significant downfall of such an approach that I've demonstrated to you. This positivistic approach, because if we have a thought, a concept, an idea, or whatever, or principle that we have in our imagination, it also influences our life, right?
Yeah.
So in a certain way we interact with it. So through that you can see that ideas and concepts also exist in the universe, right? Which positivists would completely deny. But again, as I've said, you need to use more modern philosophy to work with that. But you're absolutely right.
I'm not trying to attack anything.
Yeah. Okay.
I wouldn't vote against that. Concepts and stuff like that is in the universe, as long as you keep the difference.
What do you?
You know the difference between an object and a concept. Don't mix that up. What I would say about that.
But he's pointing out when you have a concept, it changes your interaction with the universe.
Fine.
It might directly impact your physiology, which is again chemistry and physics.
It's okay that it does it, but just be aware that it's a concept.
His voltage might have gone up.
But were all things once thought?
Say that again?
Weren't all things once a thought?
Oh God.
Yeah, please.
Can I just say there's a wonderful clip from Australian television where an 11-year-old boy was up in front of a panel of experts and he asked the question, if the universe is infinite, how can it be said to be expanding? And what he got back was just a load of waffle. Absolutely awful.
Right.
Yeah, there's also an interesting thing which you might not be aware of that I've actually asked some experts at some conferences, is that, supposedly the dipole of cosmic microwave background is caused by our motion with respect to the cosmic microwave background. So we have this Doppler shift, hot pole on one side and cold pole on the other. But the question is, if Big Bang happened everywhere simultaneously, we shouldn't be moving with respect to the cosmic microwave background, because it also was radiated from right here. So we shouldn't have hot pole and cold pole, and I have no idea how they cope with that, to be honest.
Maybe they're getting back to geocentricity.
Yeah, there is something.
Yeah. Well, yeah, no. You can have that. Then, in the expanding universe, you can have, for the sake of a gigantic explosion. One Earth goes one way, the other anti-Earth or the other Earth goes the other way, and then they are moving with respect to a distant but not infinitely far away background. So you would see the dipole.
No, I mean the narrative is that this recombination phase, it happened everywhere. So each point of space was a source of the CMB.
No, I agree with that. But you can start moving relative to the CMB later. Due to some explosion. You see well, that's the argument anyway. Okay.
Yes.
Well, I mean, what if you say that space is infinite, but any kind of material?
By the way, I never said it's infinite. I always said not finite.
Okay, no, but this is just. I mean, what about saying, okay, there's infinite amount of space, never stops, but that all the material and energy is something that expands into it? Could that be a way of thinking of an expanding universe?
That's a good question.
Well, that might be a way of thinking, but it's not what I think. It's not the way I think.
Yeah, well, part of the discussion.
Are you saying space is
Also, the observations today.
Yeah,
Not finite. It's not the same as infinite.
I do have a sense of an expanding
It's the two lines
self-awareness,
meeting at infinity.
and that our
That's-
experience
that's-
of ourselves can expand, our consciousness can expand, we can include things before that we denied or rejected, we can have a richer and more vibrant experience of being. So there is something of bringing expansion home as a process of becoming and being.
Yeah, but locally you can have all kinds of
Locally you can do
processes,
that.
but we're only a small part of the
Yeah.
universe,
Yeah.
so we can expand. There's plenty of space to expand into for us. You know?
But then the tendency is for us to then project our own, something about our own consciousness onto the universe and look for it there. So that's why I think to some degree there's the positing of beginnings and the positing of big bangs, and it's almost trying to create the evidence to support the sense of self we currently have.
Yeah.
Well, that might be the case.
No, and not
You have mentioned Houghton Arp, who questioned the redshift interpretation. The idea of expanding the universe very much depends on interpreting redshifts of distant galaxies and stuff. And he said redshift can be more to do with age and youth and formation. Would that affect your interpretation then?
No, I wasn't even talking about any particular observations. It's just pure logic, pretty much.
Because that's still a local event, isn't it? Even redshift.
Like there are other ideas, like Alexander Unziker, maybe you've heard about him, made a, recently there was a video, or maybe not so recently, but there was a video about what he calls Einstein decay cosmology, where you get redshifts from actually sort of like gravitational potential. So the more stuff the photon was traveling through while it was getting to us, the more redshifted it becomes. It's kind of a like tired light hypothesis, you know. But it also relies, this type of cosmology, on variable speed of light. This is also important to remember. And he actually quotes Einstein, who in this paper, or maybe in like draft versions of his paper about lensing, he actually said that gravitational lensing. He actually said that you can get the same result, the same gravitational lensing, by assuming variable speed of light, and not the actual gravitational lensing.
Right.
I mean the warping of the space-time.
The problem with the tired light, of course, is it doesn't explain quantized redshift, which is a subatomic phenomenon.
Yeah, that's a good point, but again, I wasn't talking about that.
No, of course.
Yeah, he's talking about gravitational redshift,
Well, It's assumed.
Yeah.
It's assumed it's due to the gravitational force, but it's much more simply explained as simple optics, where you have a variable density medium.
Yeah.
In other words, refraction.
I agree with that.
Okay then.
Okay.
Thank you.
Thank you very much, Eugene. Well, we'll break for lunch and start again.